videoing, because it makes no difference at all to the lesson. It shouldn't make any difference to the lesson. But this, as I said, this is an energy transfer, okay? So we can summarize that. This is an energy transfer. So it's one type of energy. One type of energy is changing into another type. Oops. Okay. In fact, it's not just one other type. It's changing into two other types. In this case, sometimes it's three. Sometimes it's more. Right. But that's exactly, yeah. So we can look at some examples about how when it would be more than one type. In fact, we'll do another one shortly. But if this was an absolutely perfect light, if this was a really, 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 really good light, then it would produce lots and lots of light from the electrical. So what we can do to demonstrate that is we can make this arrow here, we can make this really wide like that, and we can say that's the amount of electrical, and then we can say the heat, let's make the heat a lot smaller. So we'll say the heat is like that, and then the light is a little bit wider like that. Okay. So this bit now, this one now means that it's quite a good light. It's not producing much heat. It's producing mainly light, and of course we want it to be producing mainly light, don't we? I mean, ideally we'd like no heat at all, really, because we're not turning the light on to stay warm. We'll turn the light on so as we can see. So let's imagine. Well, in fact, can you remind me, what do we measure energy in? Excellent. Yes, it's joules. So let's pretend that we've given it 250 joules of energy. And we're going to say that the light, we had, I'm going to say 215 joules of light energy. So can you work out how much heat energy would have been produced? So go on, sorry. So if 250 is going in and 215 is coming out there, then the rest is coming out as heat. So how would you calculate what the rest is? Excellent. So basically what we did is we used take away, right? We used subtract. So we did 250 minus 215. So it's 35 joules of energy. Okay. I don't know if you can just about make that out. If we zoom in, you can read it a bit more easily. I'm going to make it just a little bit wider so as you can see it. So basically, one of the things this is demonstrating is that energy cannot be created or destroyed. Okay, all the energy that I put in, I'm going to get it out. But some of it might be light, some of it might be heat, right? Now, if I imagine, let's say we got another light, and we're going to still use the same 250 joules of energy, but this time we're going to actually produce. Oh, hang on a second. We're going to get more heat, so it's not as good as the first light, which means we're going to have less light. So we're going to make this a bit thinner. And it looks like it's about 50-50. So if we were going to say that the same amount of light, so if it's 50-50, then how much light energy would be produced if it's split halfway down, right down the middle? Well, basically, if we've got 250 going in and half of that is coming out as light, what we need to do is divide 250 by 2. What's half of 250? So if this is split down right down the middle, 250 would be 125 joules. Oops. 125 joules. That would mean that this would also be 125 joules. And this means that in this one here, we can see that 50% of the electrical energy is transferred to light. Okay, let's just move that a little bit. So 50% of that is transferred as light. Now, if it was perfect, it'd be 100%, wouldn't it? So now, what about over here? How would we work out what percentage is transferred into light there? Well, basically, what you do is you take the number 215. Oops, that's a very thick pen. Let's make that a lot thinner. It's because I was zoomed out quite a bit earlier on. So you take the number 215 and you divide it by 250. So that gives you what fraction of the 250 is going in. Is coming out. So we've put in 250 and we've got 215 out. So this is going to give you the fraction of the 250 that has been that's come out. And we want to turn that into a percentage, so we then times that by 100%. And if I do you have a calculator handy? So 215 divided by 250 is 0.86. If you times that by 100, you'll get 86, and then it's percent. Okay, so that's a pretty good light bulb. It's making 86% of the electrical energy will turn into light. That would mean that 14%, the rest of it, would have been the wasted energy. And over here, it was 50-50. Okay, so this one's a lot better. And obviously, ideally, sorry, this one on the right is not as good. So what this is called is efficiency. Okay, so efficiency is how well it does something. And the actual sum that I did here, say again, sorry? Yes, exactly. So that's exactly what I've just done there. So efficiency is equal to the useful energy out divided by the total energy in. Okay, so useful energy out was 125 divided by 250, and you would get 0.5 if you did that. But what we'd normally do, if we want the efficiency in a percentage, then we would then times that by 100%. So that's how you would work out efficiency. Okay, so I'm just going to stop that video there.